Hi guys, Mr. Dr. Logic here, and today I'm going to be going a little off topic, and I'm going to do a little chemistry. Now, basically, I want to identify something that the professor hasn't pointed out to us, which is 10 organic compounds that the textbook pretty much says we don't penalize you or we don't say you should memorize anything, but we do have a recommended list that's going to pop up 10 times over. If anything to memorize, these 10 compounds should be the case. And many of them are a variation of the same thing, but you're going to see them so often you might as well get familiar with them. Okay, now the first one and the most common one is everyone's favorite, which is your classical ketone. So just, oh my gosh, just your plain old baby. Now every other one is just going to be a similar variation of this. So this is number one. You're going to see it most often. This is what we start our reactions with. This is what we end our reactions with, depending on what the end result we desire. So number two, also this one's the most easiest. Number two is the same one, except with the H in the end. Now this one's more reactive than this one. And so I'm just going to add a little comment here saying that it's more reactive. Because of that hydrogen, oh my gosh, because of that hydrogen making it so juicy. Number three, it's actually fluoric acid, which is rather interesting. Oh yeah, and by the way, this guy's name is acetone. This guy's name is acetaldehyde because it's acting as an aldehyde. And this one, straight up, breaks all the rules. And this one acts more as a reactant more than anything else specifically, so beware of that. I imagine this section being more reactive than the rest, but with the ongoing reactions, this hydrogen seems to be the area of interest. Okay, now number four, we got this bad boy, which is actually an ester. So it's EO that, and you can already imagine what we should be looking at here. It's commonly referred to as this, or aka ethyl. I spelled that wrong. Let me just fix that. Ethyl acetate. So this is another one that the textbook flat out says. I'll show the diagram. Now this one they specifically say because this is like number three, another reactant that you're going to see quite often. It's not going to be independent like this one where it's just in some random compound with R and R1. Because usually that's how you see these acetone, this. In fact, this is the product. This is often the reactant or the product. So these guys end up being more of a reactant or more of a catalyst. Not a catalyst, but something to react it with. And then number five is just a similar variation of this, which is straight up EOE. So ET straight up just CH2CH3. This is for anyone unsure about it. And you can just call it ether. So straight up ether or diethyl ether. That's its technical name. So just like this, just like this, these two are the same. Now for number six, okay, now these guys pretty much react within the same boundary. So you're going to see them quite oftenly, at least for the up and coming midterm that I have to do, they're going to react quite frequently with three main reagents: water, alcohol, and ammonium with the correct catalyst. So they're just putting a lot of things out there. Okay, now let's move on with number six. Number six is benzene. Okay, now this one's technically a bit different because of one specific thing that I want to draw attention to. Oh my gosh. Oh my gosh. You're never going to see me draw worse benzenes than these. I want to draw attention to this. Actually, you know what? The entirety of it. I want to draw attention. You know what? This would look more concerning if it was in red. I want to draw attention to this. And then I want to compare it directly to phenol, which is actually, if I can get it right this time. There we go. This. Now, a big difference here is that you got two bad boys here and you got one bad boy here. Now, what does this technically mean? This means that this is reactive, and compared to this is very unreactive. And so why is this important? It's because well, one, we're going to see this quite frequently, and two, we should know how they're going to behave coming forward, because we know that the phenol part, if the phenol part is not going to be the one reactant, then we know how it's going to behave, especially when we compare it directly to number 8, which is exactly, oh my gosh, there we go, there we go, there we go. So you can immediately see what we need to draw attention to. It's this OH group right here, which is going to be the main reactant. So this one is called phenol. And so if you guys need the names for this one, benzene, everyone knows your classical benzene, and everyone knows your phenol. These two are actually very different. Phenol. Sorry, sometimes I get the name mixed up. E-N-L-Y. Okay. So yeah, these two are actually very different. For that reason, don't get the two mixed up. Okay, now I want to compare this to number 9. Ignore that. Number 9. Which is actually toluene, which is another variation of this. Now you can start to see sort of a pattern here. Common reactants, right? And so this one specifically has a methyl group. And you can obviously see what we need to draw attention to, because it is going to be the part that reacts with the molecule. And so this is technically called toluene. Okay, and now for number 10. Oh, yeah, now for number 10, which is actually our most common base. Forgive me, this is actually quite hard to draw. Oh no, I drew that part wrong. It is actually our most common base, which is, let's end it another way, pyridine. Okay, now I understand I'm not the best for spelling, nor am I the best for pronunciation, but the point here, I want to address that this is a strong base, since this will attack a specific hydrogen, and this will break the bond for an instance like this, given the right conditions. And that's what I want to draw specific attention to. It is, in fact, a strong base. And so again, so for most of these, they're very they act as reactants and major components. I just wanted to draw attention to this phenol because, well, there's so many variations of how they react. And then these benzene is quite actually very different. And something else I want to draw attention to is the vinyl group and the allyl group. Now, we haven't brought much attention to this, but this is actually needed for future reference when considering more and more going forward. So you will often see this, you'll often see this. Now, a difference between the two here is that this one's called an allyl group, and this one is called a vinyl group. Now, what's the difference between the two? Well, one's stable, and the other one is reactive. And so determining the difference between the two is actually going to be a little interesting, since the textbook goes into much detail, and so one common example they use, and I shall give reference to right here, is benzyl acetate and phenol acetate. So yeah, here we're going full circle. So let me just get the drawing for this correctly. So yeah, and like that, and there we go. And so this one, 0. Now we can already see the difference between the two here. This one is not so different as this one, but this one is much more closer to the oxygen, so it's going to make that one more stronger, and we already know it's unreactive, as we're implicitly told by the textbook, and this one is more reactive. So if you see something like this guy is going to be destroyed, get lost, something's going to happen to this, and I don't want to spoil anything in the future without confusing you guys. And I can say the same thing for the benzyl and the phenol. In fact, I'm going to make another example right here, straight up, with the benzyl acetate and the phenol acetate. So I'm going to do the benzyl first. Up, down, that. And we're going to do a little versus thing. Versus. 0. Now you can see, now you can already see that this bad boy is pretty far away from the oxygen when compared to this, and because of that, this is totally exposed, and this is the beautiful pressure point for attack. Now obviously this is where all the attention is going to be, but the oxygen is going to do some weird stuff where it attacks the hydrogen or the proton, and then this comes into play, it becomes a double bond, and then snap, this gets cut off, and then yada yada yada. This is what I'm foreshadowing in the future. And I promise the video is not going to be so awkward. I was just getting these 10 compounds out there to highlight as they are important, because the textbook flat out says it, and no one gave us a particular guide, not even the professor. So I just want to point this out and just bring awareness to that. And I promise the rest of the videos won't be as awkward, and it'll be more direct and informative and much more entertaining. That is all for this video. I hope you enjoy.